Hello and welcome. In this video, we're going to implement binary search in JavaScript. So you can see here the prompt. It says, given a sorted array and a target value, implement binary search to return the index of the target value. And so we've got some example data here. We have this input, which is a sorted array, and it's important to keep in mind that binary search only works on sorted arrays. And below that, we have these indices, which I've included here just for demonstration purposes. And so we've got a target value of 9, and we would expect that to return 7, because 7 is the index of 9 in this array. Now, we can approach this problem with linear search, and that would involve starting at the first element and then iterating one at a time, checking to see if the value at that index matches the target that we're looking for. And if it does, then we just return the index. The problem with linear search in this case is that it has a time complexity of O of n, which means that as n grows, the runtime grows linearly in proportion to the size of n. Binary search, on the other hand, allows us to divide the problem in half with each iteration. So that has a time complexity of O of log n, which is much more efficient. And what that means is that as n grows, the runtime grows much more slowly relative to the growth of n. So how do we implement this? So the first thing we want to do is create a left and a right pointer. So we're going to create a variable called left, and we're going to assign it to 0, because that's the leftmost index at the beginning. And then we're going to create a variable called right, and then we're going to assign it to array.length -1. And that is the rightmost index. And so what we want to do then is come up with a way to loop over the array. Now, in the beginning, we don't know what the size of the array is going to be, so we can't use a for loop, but we can use a while loop instead. So we can set up the while loop. Now, what's the condition we want to check for inside the while loop? So you can imagine, right, visually, at the beginning, the left index is going to be over here, and the right index is going to be over here. And each time we divide the problem in half, the left and the right index are going to actually move closer to one another. And if the target value doesn't actually exist in the array, at a certain point, left and right are going to go past one another. So we can say that while left is less than or equal to right, that can be the condition during which the while loop runs. Now, inside the while loop, the first thing we want to do is figure out the midpoint between left and right. So we'll create a variable called mid. And how do we get to the midpoint? So if left is 0 and right is 10, well, the midpoint is here. So you can see that it's the average of the two values, right? So we can do left plus right divided by 2. Now, a couple of things. We want to wrap this in parentheses, but we also want to wrap this entire thing in a math.floor, because if the sum of left and right is an odd number, then we're not going to get an integer here. So we want to make sure that we math.floor it so that midpoint is an integer. Once we have the midpoint value, what do we want to do? So the first thing is, if the value at that midpoint index is our target value, then we're done, right? That's the midpoint, that's the index that we want to return. So we can do an if statement. If array bracket mid equals target, then we just return mid, and we're done. Else if, what are the other conditions? So if array bracket mid, so this is the value at the midpoint, is less than our target, then what do we want to do? So what are we saying if we say that the midpoint is less than our target? So imagine that we're here at this index, and the value is 7. Well, this is less than our target of 9. So we want to eliminate the left half of the problem. So how do we do that? We move the left pointer to the right of the midpoint. So then the right pointer would still be here, and we've eliminated this half. And we move it to the right of the midpoint because we've already checked the midpoint in this block here. So all we have to do here is do left equals mid plus 1. And then finally, we have one more else if, but it's actually just an else because it covers all the logical conditions. But essentially, that is array bracket mid is greater than the target. So if the array bracket mid, so the value at the midpoint, is greater than our target, that would mean that our target is on this side of the problem. So we'd want to eliminate this half of the problem. How do we eliminate this half of the problem? We take the right pointer, which is here, and we move it to the left of the midpoint. So it would be right equals mid minus 1. Now, this while loop, if the target is in our array, this while loop is going to return, because eventually we are going to find a point where the midpoint is equal to the target, and then we're going to return that midpoint index. Now, if the while loop doesn't return the midpoint, then we want the binary search function to return -1 to indicate that the value is not in our array. And just to make sure that this works, I'm going to copy this function. Well, actually, let's invoke the function first, binary search, and we'll pass in this array as the first argument, and then our target is 9, and this should return 7. So now let me copy this. I'm going to switch over to Chrome. We have a snippet open. I'm going to paste this, and I'm going to hit run. And you see that it finds the right value. It finds the right index. Now, let's say we're looking for 17. That was at the 10th index, right? So let's try it with 17. And you see that it returns 10. And if we try it with a number that's not in, we see that it returns -1. So I hope you enjoyed that overview of binary search in JavaScript. If you found that video helpful, please be sure to hit like, subscribe, and I'll see you in the next video.